My name is Terumi Laskowsky. Wow, it's like booming voice. So I shouldn't be talking too loud, I suppose. Thank you very much for coming. And this is a 90-minute session on blockchain. As was introduced, I am a computer security consultant. My background, I used to be in the Army as well. I was a military police officer. So I guess I've been doing security forever. But back then, I was doing physical security. Now, for the past 25 years or so, I've been in the field of digital security. And I'm a consultant, but my specialty is what's called pen testing. So if you know what a pen testing is, there are network pen testing, there are OS pen testing, but my field is application pen testing. So when I attended an AFCEA event, international event, in Washington, D.C. several months ago, I was there specifically because there was a topic on blockchain. And I was very, very inspired. So I asked Mary if I could actually do a talk on this time, and here I am. Okay? Yeah. So I hope you enjoy the content. Because I'm coming from the security perspective, a lot of my talks will be centered around security and how do we get trust, or how do we acquire trust through security in blockchain. And at the end of the presentation, I hope that you'll be able to kind of think about it and say, well, how do you feel about that, right? How do you feel about that trust that currently exists in blockchain in general? Now, when I talk about blockchain, we have to also talk about the application that it supports. So a lot of people are familiar with Bitcoins, perhaps Ethereum, because these are the implementations that are very, very popular. You know, blockchain doesn't really exist by itself. But most of the security and trust that I'll be talking about is inherent in blockchain itself. So let's get started. Any question before I get started? No questions at all? Everybody's here for CEU? Yes? CEU is a good thing, right? I get CEU too by teaching this class. Yeah. All right. Okay, so some parts of it may be hard to see. This is the first time I've seen this presentation like this. The link, this is an open presentation, so if you could get a hold of the link, you'll be able to go ahead and go back on it. I have some active demonstrations inside the link, so if you're interested in actually doing the demonstrations that I'm going to show you today, please go back into the slides. They're made available to you, and try it out yourself. Okay. All right, Connecting Strangers, Blockchain Technology and Distributed Trust. Well, the title probably should be Blockchain Technology and Distributed Non-Trust. Right? Because blockchain is about not having to have trust, and yet you can still do the transaction that you want, knowing that you won't be, somebody won't steal your coins, or they'll try to compromise your application, right? So we'll see how that turns out. So the inspiration for this, as I mentioned, was the presentation that I heard at AFCEA event in Washington, D.C. There, Dr. Sean Mannion actually presented. Now, his topic was about blockchain and how his company was implementing blockchain. But one thing that he mentioned, he said that science will be blockchained by 2025. And there's a link here that I have that says presentation link here. If you were to click that leads you to the AFCEA, his presentation. So if you're interested, please take a look at it. He talks about medical blockchains. He also talks about research blockchains. And also, he also talks about a small project that he did for DoD relating to, I believe it's PTSD and the treatment of PTSD. And those activities around treatment was put on blockchain, if I recall correctly. Okay, so he does actually have an actual project running on blockchain. Okay. So that was my inspiration. And as I got more and more into it, I really did get more interested, mainly because if you were to hear, let's say, blockchain on YouTube, or if you Google in blockchain, they talk a lot about disruption. Right? They're talking about industry disruption. So what they mean by that is what industries will be gone because of blockchain in several years. Right? And the reason why I got really interested was because one of those industries, they said, was cybersecurity. I said, oh no, cybersecurity, I thought I'll have my job forever. But then they said, no, you'll be blockchained. So I was really interested. So how's that going to happen? Right? So we'll see if they can actually replace cybersecurity and me. Right? Okay. So it's a survey, right? And my background is information security. It is not blockchain. But my interest is about security in anything that my customers use. And I have several customers that are really considering blockchain. And I'm sure that if you were to look around, you'll probably see here and there, and perhaps you may be also involved in applying blockchain to your existing businesses, or hearing about certain things going away because they will be replaced by blockchain. Right? So I think the talk is a lot. So I said, yeah, let's do a survey. So my plan was to just go ahead and just take a look at what's available online, and come up with some clarity on especially the security part of blockchain. But as it turned out, I was just overwhelmed with massive amounts of information. It was just amazing. And it's just going in all sorts of directions. So we're talking about investors, right? Investing in crypto coins that are powered by blockchain. And you have companies, the other field that I'm interested in is gaming, right? Gaming, not as in gambling gaming, but games. And there are, it's still small, but a group of people that's coming up with applications so that developers can create games, distributed games, without centralized management of, let's say, game resources. Right? If you want to buy a sword, hey, it's in the blockchain. If you want to buy metals, hey, it's on the blockchain. Right? So these are the type of direction that they're going to. So what I did was, what I usually do when I'm overwhelmed, was to take a break, take my dog for a walk, and usually that kind of calms me down. Right? And then I finally did get some clarity, not complete. Right? So please don't expect perfection from my survey today. It's a moving target. Right? And the technology itself, some parts I think you probably need a PhD to kind of explain, and I don't have one of those. Right? So I can't explain not all the technologies. But because it's a survey, I'm going to take the liberty of talking like I know what I'm talking about, but it's going to be a very high-level discussion. I hope that's okay. This is what I learned as an instructor for the past 20 years or so. Right? So if I'm wrong, I'm going to put in here, say that, look, this is not my original information. I got it from all kinds of sites, and not all those sites are correct. Right? As a security expert, I know that to be true. All right, but I hope it's interesting enough, and I did do some due diligence on these. So here we go. Oh, by the way, if you were to go to my presentation material, I use a tool called the Brain. Right? So the Brain, and I don't know why it's not showing up. On the right-hand side, it should eventually show up. It should. It's a tool that I have. It's like a mind mapping tool. So there we go. It's a little bit slow here. But that's also available to you. Here, I just put a whole bunch of stuff in there. Whatever I find, I link. So you can click by topics. And I have this topic called disruption. If you click on disruption, you'll see industries that I found. And then eventually I'll be putting in some specific links that goes to those kinds of projects. Right? So it's my map. It's open to you. Right? So if you like to go to it. So there you go. That's a little blockchain thing. Okay, so that's how I organize my thoughts. Okay, here we go. All right, so how to organize. That was a big deal for me because, like I said, there's so much information out there. And so I really had to focus. So how do I cut this pie, which is blockchain? And the way I came up with it was there were two ways that I can actually talk about this. One is a technology cut. So looking at blockchain and related technologies as a technology. Right? But the thing is, that's my go-to place. I'm a more of a technical person. So this is my favorite way to get into it. But I know that in real life, technology is not how a lot of companies go into it. A lot of companies go into blockchain because of what it can do, not how it's done. Right? And so they're very, very excited about all these new applications, new systems that they can bring into the market using blockchain. Blockchain is still an immature market. There's lots and lots of opportunities here. So I thought, Okay, so there is a technology cut. And we'll be covering this a little bit, and the way I organize the technology is in a layered model. Right? It's like I'm a network person, so I do layered models, if you know what an OSI is, Open Systems Interconnect. I teach that all the time, day in and day out. So naturally, I got this layered thing going. Okay? But the layer is not hard. At the bottom, you have blockchain, which is a technology that supports all these applications. That's what it means. So whatever you have on the bottom supports what's up high. So for example, Bitcoin is supported by blockchain technology. Ethereum is supported by blockchain technology in general. I'm not talking about one version of blockchain. I'm talking about several different versions of blockchain possibly, but blockchain in general, that's the technology. And then on top of that, so protocol, what I mean by protocol is certain agreements that you have in talking to, let's say, different parties. So, right, in the military we have protocol, right? We actually have people like what's called protocol officers, don't they? Right? So they know how to interact with others. And that's basically what I mean by protocol. So supported by blockchain, but actually a Bitcoin protocol, Ethereum protocol, knows how to talk to each other to do certain things. And then those protocols actually support the applications on top. And I think many of us become familiar with blockchain in general through the crypto coin systems. Right? So people are investing in crypto coins, Bitcoin, Ether, and there's zillions of other coins out there. So that's one. And then there's something called the smart contracts. The smart contract is where you can use all the technology and the protocol not for money, not for cryptocurrency, but for application. So distributed application, they call it DApp. And I'll go a little bit into that. DApp doesn't really talk too much about trust, so I won't go too deeply into it, but just understand that it's not just about crypto coins when we're talking about blockchain. So I said, hey, okay, technology cut. Right? That's one way of doing it. But then there is another cut after all. It's called the solutions cut or the business cut. Okay? So from the business cut, that's right. I see you guys like touching your head. That's right. This is for me to check who's actually looking at my presentation. That's right. So if you have your head cocked, that's right. There you go. I can tell who's looking at my presentation. So you have the investors, right? There are certain things called initial coin offering, right? People try to make big money at the very beginning of the game and then make money going forward, right? So there are investors investing in coins and smart contract applications. Okay? And, of course, there's some certain things called the crowdfunding. So there are many, many blockchain-based new technology startups coming up that is seeking money through the crowdfunding. It's huge. Right? It's becoming a very huge market. And then you have the businesses, right? Those disrupted businesses or will be disrupting businesses. Those are the business models where they say, look, okay, I'm not too sure about the technology, but I know what it can do. And this is what I want to do. So from that is a business cut. They'll be looking at the business models. How do I make money out of this thing, right? How do I integrate this blockchain technology to my existing systems? Or do I have to get rid of my system altogether and go blockchain all the way, right? So these are the kind of things that the businesses will be concerned about. Okay? And then you have the developer. I'm not exactly sure which site it is, but there are, I think, several sites where you have freelance developers. And I'm hearing that blockchain developers, right, those people who is actually able to program these applications based on blockchain, the market is really like going up at a very high pace. So for me, for sure, I know, because I'm actually working on one of these projects, is that universities want to teach blockchain to their students. And of course, companies want to teach blockchain programming to their employees and their developers. So I'm sure there are many other components here that I probably missed, but those are the three major ones that I thought I would go after. So that's the way I sort of organized this little piece of pie. Okay? So the approach that I took, right, then I said, it has to be about distributed trust because there's just too many things out there. I'm not going to be talking about investment. I'm not going to be talking about application development. I want to be talking about trust because that's very close to my heart when it comes to security. So cover from the perspective, right, firstly, from the business model, right, because this is not usually how I start, but I want to try it out this time around. I want to go from the non-technical, right? So going from the business model perspective, and then next talk about technology that supports it, right? So we're talking about the blockchain itself, the technology, and just a little bit on smart contracts. But most of the discussion will be by blockchain, because that's where the basis of distributed non-trust, right, or the trust in the system, but not trust in the participants, is actually derived. That's where you find it. So far, so good? It's okay? All right. Okay, so let's go first from the solutions cut. Okay, so if you look at it, the business disruption. So if you're looking from a very, very high perspective, blockchain, what is it? I'm not going into details. That's for the second part, right? So I'm going to purposefully not go too technical on this one here. Okay, so it's distributed. So it is a distributed, immutable, that is you can't change it, okay, and transparent, that is anybody can see, and it's a ledger, right? That's what a blockchain is. Blockchain is a ledger. So if you are finance types, you know what a ledger is, right? And if you work in the bank, you work with ledgers, right? So that's basically what it is. That's a blockchain. Right? And maybe it's a yawn, right? So, oh man, we're talking about ledger, right? Okay, even though it's distributed and immutable and transparent, okay, it's a pretty exciting thing. But we'll see how this blockchain is all the hot discussions, right? So first of all, ledger is a record of transactions. It doesn't have to be about money, right? But the money goes in very nicely with ledger, because that's what we usually associate ledgers with somebody sending money, somebody giving you money, and all that. Right? And plus getting all the totals and such. Right? So that's a ledger. Okay? And ledgers change all the time. Okay? And usually it's in a central location. But because it's distributed, we're going to distribute the entire copy, right? Exactly the same thing, to many, many people. Okay? And you may not, appreciate the why is this thing, but once we get to the technology part, you probably appreciate why it is the way it is. But just understand that that's what it is. It's distributed across the internet. And of course, blockchain relies upon the internet. Okay? So internet is a given. And once something is recorded, you can't change it. You can't say, oh, I made a mistake. No, can't happen. Right? In fact, that part is inflexible. Right? Because if blockchain allows you to go back on a certain record and then modify it, then this actually breaks the security model that we're talking about. So that means you have to kind of start to think and say, yeah, but the kind of stuff that we do, we have to make modifications all the time. Okay, so if that's the case, maybe blockchain is not the solution for you, right? Blockchain is not a solution for everything. Blockchain solutions for certain things. Okay, so we'll see what those certain things are. And what blockchain fits for, it does very well. But I'm sure there are areas like businesses that you won't be able to replace with blockchain, okay, because it doesn't fit this model. But anyway, once recorded, transaction cannot be modified. And on top of that, anybody can see the content of the ledger. Anybody. Okay? And I don't know if you've heard about all these, because I do security, and we hear things like ransomware. Right? You've heard about ransomwares, right? So hackers send you like malware, and you accidentally click it, and then it encrypts your whole hard disk, and they want you to send bitcoins to them. Right? I think one bitcoin right now, it changes because it changes depending on the market conditions. But bitcoin right now, I think it's worth around $6,000 or something. Okay, so if they say 2 bitcoins, you're talking about $12,000, right? But I don't want to go too much into detail about cryptocurrencies, but you don't have to buy a whole Bitcoin. You could buy fractions of Bitcoins. So you could say, I think I'd like to have $500 worth of Bitcoins. Okay, so it would just be a fraction. Okay, but anyway, but the thing is well, how do hackers do it? If the hackers receive Bitcoins for their deed, which is a legal deed, right? But anybody can see the ledger, why would they use Bitcoins? Wouldn't they be found out? Don't you think that to be true? So if people can see that I just got a whole bunch of money from a whole bunch of people, right? People say, hey, this is pretty suspicious. Why is Terumi getting all this Bitcoins all of a sudden? Okay? And all those people that paid money were the victims of the ransomware. Oh, there you go. It's like a big flag that says, here, I'm the hacker. Okay? Well, and let me tell you, sometimes it works that way. Right? Not everyone gets away with using Bitcoins and stealing and threatening. So sometimes they do. But the Bitcoin system itself supports anonymity. Right? So you can see that there's a lot of transaction happening, and you see who is it coming from and where is it going, right? You'll be able to see that. And everybody in the world is able to see it. But the thing is, the tie between who it is and the actual person is anonymous. Supposed to be. Okay? So unless a hacker makes a mistake, or because of legal requirements, that you actually have to reveal that account name and your actual person, then of course you'll be found out. And there's been cases where it has been found out, and people have gotten arrested already, right? So, but the thing is, in general, that's not how it works. In general, you can see all the transaction, but you're not supposed to be able to tie that back to actual people. And that's how it supports anonymity. Okay? So there are faults to it, right? Yeah. What's expected, what's desired, and what happens is different. But in general, this is what they seek to do. So that's blockchain, right? That's blockchain from a very, very high point perspective. Okay? So let's talk about one of the terminologies, distributed. Okay? So instead of being centralized, it's distributed. That's one of the hallmarks of blockchain. Okay? But when we're talking about it, we usually, if you Google, right, distributed and centralized, you'll see this picture. Okay? But this is not quite correct. Yeah. So this one says centralized, decentralized, and distributed. Okay? Actually, we'll talk a little bit differently. So let's talk about this. This is another picture done by another person who researched in this area. Centralized. Okay, that looks pretty good, right? So there's a central point, and you're controlling everything from there. So that's pretty similar to what you just saw. Okay? But that's where the differences, the sameness stops. The next one, distributed, the terminology of defined as this. That's distributed. Okay? So there are many, many different subsets of distributed networks, right? Or distributed relationships. Okay? And so without going too much into the weeds, because I don't quite understand the total picture, I don't think. But when I read this says, okay, distributed could be combinations of centralized. So you can have a whole bunch of stuff that's centralized and then put them all together, and that's also considered distributed. Okay? So why is that important? Because that's not, that part, the high part is not blockchain. Blockchain seeks to be peer-to-peer. So if you're thinking about blockchain and the relationships that what's called nodes have with each other, okay, whether it being computer nodes, right? Mostly they're talking about computer nodes that participate in this blockchain network, is peer-to-peer. So what is the difference between peer-to-peer and decentralized? In peer-to-peer, everyone's equal. See, that's the main thing. Okay? So what's the difference between decentralized, that thing one above it, and peer-to-peer? Well, there are certain hubs, aren't there? Right? So you have certain hubs within the network, and then those hubs are connected together. Right? So what's so bad about that? Well, there's nothing bad about hubs inherently, but what happens is once someone builds a hub, that person has a tendency to overtake, right, the operation. So there's a possibility that it won't be equal, that whoever owns the hub becomes more powerful than everybody else. Because look, if I were to say, if I'm one of the hubs, right, like if I'm one of the hubs, and if I say, look, I'm providing all this networking, I'm providing all these devices, you pay me. If you don't pay me, you don't get to access my hub. And guess what? My hub is a great hub. And if you don't, belong to my hub, you're going to be losing out on a lot of things. All right, so now I'm putting pressure, right? So that could not happen in peer-to-peer. It should not. That's why and blockchain is, what's interesting is blockchain is not just about technology, it's all about the political, right? All about it's about ideals, right? So the people who came up with blockchain was, I would say, idealists, okay? And when it came out was like back in 2009. And if you recall what was going on in 2009 was that some banks were going out of business, okay? So you really couldn't trust and you would lose your money, right? So they were saying, look, I don't want to put my trust in that bank that perhaps mishandle my money and mishandle investments and now I'm out of money, right? So instead of that, just get rid of them because they're no good and I want everybody to be equals. Right, so that's where the whole thing came from. Okay? So that's the distributed that we're talking about. We're talking about peer-to-peer. Okay, peer-to-peer. And there it is. That's where blockchain is. Right there, peer-to-peer. So then, let's take a look at another one, disruption. But then what's all this disruption about? Okay, so we're talking about something that is centralized, hierarchical nature, okay, vice the peer-to-peer. So I just have some technical stuff in there so if you are technical types, if you understand certification authorities, right, if you understand digital certificates, right, this picture probably is perfect for you. But if you don't, that's okay. Let me give you another example, right? So what we're talking about here, what kind of businesses are targeted as a target of disruption with blockchain is if you have a system where the trust in the system comes from one location. Trust in the system comes from one location. So take, for example, a bank. Right? The reason why you write checks, the reason why you can use banks is because people trust the bank. It says, okay, I can trust Terumi's bank because Terumi's bank will not let her draw more money than she has. Right? And so if I get a check, there's a bank's, vouching for the fact that that's okay. Those books, we keep Terumi's books. We'll keep, pluses and minuses in check. So the fact that she's giving you this money, yeah, she does have it in there. But that thing, that trust that everybody has, comes from the bank, not from the individual. So I could probably give my check or whatever, payment, to people that doesn't know me, but knows the bank, right? If the bank is okay. So that would be the central location where you gain trust in the whole system. If you lose trust in the bank, then you probably won't use the bank. Right? So here's another one. I travel all the time. And every time I go to, let's say, to a different country, they look at my passport. Right? So why would a passport serve to confirm my identity? Well, it doesn't in a way. Right? It does not in a way. Unless whoever's checking it trusts the fact that the passport that says U.S., it says, okay, we trust the State Department, right? But they'll always check to make sure that the photograph hasn't been altered, right? It says, okay, it hasn't been altered, and I trust this. I don't know who you are, Terumi, but I trust the fact that the U.S. government trusted you enough to give you the passport, so we're going to trust you. Once again, this is the central location of trust, right, for whatever the system it is. So if you could think of anything else that does something like that, where it says, yeah, my locus of trust is there. And the trust that I give you is called transitive trust. I don't trust you directly. I don't even know who you are. But because I trust the other party and they trusted you, I trust you. Right? So that's a transitive trust. So if you see a system like that, it's wide open to be disrupted by blockchain. Right? Yeah, okay? So anyway, so that's a little pyramidal thing, okay, that I have in there. So then, if you have decentralized, right, decentralization is a hybrid, right, as I mentioned. So it's a hybrid. So there's another system where there's the opposite, not the opposite, but the different type of certification authority, the example that I showed you, there's something called Web of Trust, okay? There's a software called PGP, pretty good privacy, that's used for encrypting emails and such. If you don't know, that's fine, okay? But they also have to trust everybody else. But in their model, individuals trust each other. So I'll say, look, you send me an email and I know who you are. I trust you, right? And then who do you trust? Oh, you trust Bob. Okay, so I'll trust Bob too because I trust you, right? But it's an individual trust, right? Then I'll say, let's say Bob trusts Sally and Sally trusts Tina, okay? So because I, trust Bob, but I'm not sure about Sally because it's kind of far out there. It's not a direct trust. So I'll say, I kind of trust you as far as I can throw you type of stuff, right? So the trust is in the eye of the beholder in this case, right? But still, there is some way for the system to create trust. And this one is directly. I say, okay, I see you. You sent me an email. I trust you, right? And then you telling me that your friend, okay, I trust he or I trust her too. So this is basically what a web of trust is. This is not blockchain. So in blockchain, peer-to-peer, right? Peer-to-peer, okay? Everybody's equal, but you may not know anybody. So you trust the system. You don't have to trust the individual. You don't have to trust whoever's sending you money. You don't really have to trust, so to speak. You do in the end, of course. But in the blockchain world, there's no need for you to create that trust that says, I got to see you and meet you before I send my $50,000 or something. I don't have to do that because I trust the system itself. And the system is the blockchain. The system is the blockchain. Okay? But there are, just to qualify, if you were to look and say go to Google and say peer-to-peer trust model, right? Peer-to-peer trust model, there's like a whole bunch of research papers on the topic, right? So I do have a link there, other models there that supports peer-to-peer. But as it applies to blockchain, there is no need to trust individuals, but you do have to trust blockchain. So my question then on this survey is, can you trust blockchain? Right? Under what information, under what reasons would you trust blockchain? And do you feel comfortable with it? Because we've had problems with applications that are based on blockchain. People have lost millions, literally millions, in the blockchain type of supported applications. Okay? And I could probably touch on just a little bit as to why that happened. Right? It doesn't happen every day. Mostly it works fine. Right? Mostly it works fine. But when you try to add something new, everything goes haywire. Right? And the one where I think it was like $57 million was lost was an attempt to do something new with the blockchain technology, and they were like, was not a complete solution. Anyway, so there you go. So business disruption. So let's take a look at an example, right? So the first place where the industry that's already been disrupted is the banking and financial industry. Okay? So now you have a central authority issuing you money, like the bills. Like you don't get to print out bills, although some people do try. Okay? With blockchain, you don't need them, right? With blockchain, the money, the cryptocurrency, just comes out of the air, right? It's just created. Right? And there is, of course, a certain system how they're created, but they're just created out of thin air. Okay? And you don't need a central authority to give you money, right? Or to create money. Okay? So there you go. Cryptocurrencies, Bitcoin, Ether, etc., has already started to disrupt the banking industry. Now, some companies, some banks, and some financial organizations are embracing Bitcoin. It says, okay, you could pay me by Visa or blockchain. Or they'll say Bitcoins, right? Or they'll have all different types of cryptocurrencies. So they have embraced it, right? It says, if I can't beat you, then we'll be friends. Okay? Yes?
I heard Malta's government went all blockchain.
The coins, you're talking about financial?
Financial.
Okay, because there's certain governments are turning not just money, but the processes themselves, right? The government activities are now on blockchain, right? Yeah, so there you go. Yeah. And I'm not sure. See, I mean, they're brave, right? They're really going into the brave new world. Because, as I mentioned, there's certain technology stuff that's kind of like half done still. It's not fully mature. And there are certain issues that people, as I speak now, are working on right now. Right? So things are changing in the blockchain world. So, but the thing is, if you never try, right, you'll never know. So, yeah, that's something. Okay. And then you have something called smart contracts. So smart contracts, I think I mentioned, does not have to be anything to do with money. Doesn't have to be coins. It can. You can do it in combination. But it's almost like this. If you wanted to create, let's say, I don't know, something like Disney World type of stuff, right, with a whole bunch of rides and things, okay? So if you go to Disney World, I think you have to pay money to get tickets, and then you present your tickets to the ride, and they take your tickets and stuff, right? So the idea is, well, I'll just give you tickets, right? So these things, they'll give you tokens, okay? They're not coins, but they're tokens. And then you could take those tokens, and in the system where those tokens make sense, right, you can use the tokens to receive services, okay? So, but, you know, for example, you can't take those little Disneyland or Disney World tokens, go to the outside of Disneyland and say, hey, you know, give me a cup of coffee, because look, I got Disneyland tokens. No, right? It doesn't make sense. But it makes sense in the world, which is Disneyland. So with big blockchain-based token, which is what's called smart contracts. So if you thought smart contract was about contracts, sort of. Yeah, you can actually create like contracts based on that, but it doesn't have to be. It just means that it's programmed. You can actually create data, not just coins. Right? So you can create a world for yourself where those tokens make sense, and they're based on blockchain. Right? So that's basically business that could be disrupted. So let's take a look at, right, business disruption. We'll look at examples, okay? But I have to tell you, at this point, I have to make certain assumptions, and I know what those assumptions mean, but, you know, I'm not going to, all right, so, but I couldn't find another word for it, so I'm just going to use assumptions, okay? Assume that blockchain is trustworthy. I'm just going to make that assumption, right? Because if I can't make that assumption that blockchain is trustworthy, I can't go forward with these disruptive technologies, right? But then when it comes to the technology part, we'll kind of look and see, okay, so where do I come from saying that this is trustworthy? And, you know, I'm not 100% convinced yet, okay? All right, so details will be examined at technology cut section. Okay, so let's take a look at then some examples. Okay. All right, so how many of you have taken Uber? Yeah, there you go, okay. And I was so, once again, same with blockchain, I was really like enamored with the Uber. I work in Seattle a lot of times, and boy, going around in Seattle, Uber is it. I mean, that's like the best thing in the world. Taxis, horrible. They're kind of scary, right? Anyway, but Uber, if you listen to the disruptive effect of blockchain, poor Uber. They always talk about Uber, so I'm going to talk about Uber here, right? Okay. All right. So Uber. Right, the way it works, and by the way, so because I was so enamored with Uber and how it works, I became an Uber driver. So I'm an Uber driver in Hawaii. And I haven't driven, but, you know, I got the taste of it. Right? I get to go see all the places that I would never go see at the times that I would never be outside the house. but anyway, yeah. So how Uber works is that, you know, you either are customers of Uber or you're the driver, and of course you could be both, right? But you have those two distinctions because you got two different apps, one apps for a driver and one apps for the customers. And then if you're a driver, like myself, you have to go there and you have to provide the paperwork for your car and paperwork for yourself, and they do a background check and all that, right? So even though you hear some scary things about, you know, some crazy Uber driver doing crazy things, there is a type of vetting that goes on. So not anybody could become a Uber driver. Right, so they do a background check. I'm not exactly sure what they do, but it took me like 3 days or something. Right? And then, so there's that trust, right? So why would you, as a customer, kind of say, okay, I don't know who's coming, but I'm gonna ride in this stranger's car, right? Why would you do that? Okay, because Uber have done some vetting, and you say, okay, all right. So there's some recourse if there's something bad goes on, right? And plus, I don't handle money because, you know, I register my credit card with Uber, and Uber pays the drivers, and I don't pay the driver directly, right? So there are a lot of things where, if you're handling money, it says, oh yeah, the driver's going to steal my money, he's going to rob me, whatever. That doesn't, so those kind of things doesn't have to happen. So there are a lot of nice things about asking Uber to do that, okay? Plus, my concern was, well, when I'm a driver, for Uber, in those periods, let's say, like in that period of 30 minutes or something, while I'm giving the ride, what if I get in an accident? What happens, right? My insurance doesn't cover the customers, but Uber's insurance covers the customers, right? So there are a lot of nice things that Uber provides, right? So, but Uber is the central company, and everybody has to go through Uber to enjoy Uber services, right? Makes sense, right? So and the trust that you have on the driver, and the driver's trust in the customer, because Uber does vetting on the customers too, right? You do know that there is a reputational system for the drivers as well as customers. So if you look at your app, you'll see your, like 5-star or 4-star or whatever as a customer, So when I found that out, I said, oh, okay, I'm going to take a look, as a customer, and I see I'm like 4.7. I said, what happened? Who rated me low? Right? I should be 5 all the way. Like, what's going on, right? But anyway, but I can't see which driver did that, right? I can't go after them. But anyway, so I know, right? It upsets me that somebody gave me less than perfect as a customer. But anyway, so that's Uber. So how would blockchain disrupt this thing? People say, well, how much money does Uber take away from the drivers? And how much is being paid for by, let's say, customers, right? So if Uber went away, and if everybody was able to kind of do a peer-to-peer thing, we don't need Uber, right? And maybe we could bring down the cost, okay? But of course, things are not as easy as that. But the thing is, when they talk about disruptive technology, they kind of talk as if, oh, yeah, just get rid of it. Right? Get rid of the central authority. We don't need it because blockchain provides that, okay? So how would that look like? Okay, so this is basically what it will look like. So in the center, you have this mesh of networks, right? And just imagine, as a customer, you have an app, and drivers, they have an app, and those apps do not go through any central authority. It just goes straight to whoever needs it, into the network, into the ether, right? So you can make a connection with the driver directly. Okay, make it directly, and you can pay using, I don't know, cryptocurrencies. Maybe you could pay in Ether. Maybe you can pay in Bitcoins. You don't have to, handle money, just like Uber. Okay? And reputational systems, sure, right? Because blockchain allows you to add data, too. So you can put reputational systems on blockchain. And on top of that, Uber, they've been kind of successful, sort of, with the automated, right, driverless cars. So if that's the case, you don't even need people. All you need is cars, right? And if there are some gas stations or electrical pumps or whatever that's also just as automated, well, then the cars can actually go fuel up by itself and pay with Bitcoins and then go to the customer, and there'll be no driver, and people just get on. And look at that. Blockchain allows that to happen. Okay, I'm not sure how comfortable you feel about not having a driver there, or maybe having the lady who had the accident with the Uber driver, right? She was like texting while somebody ran in front of her and she killed a person. Remember that incident? Yeah. So I have a feeling that the technology is not fully there, but eventually it could. And they call this DAO, Distributed Autonomous Organizations. That is, once you bring up an organization, there's no man in the middle. Lately I've been calling no person in the middle. But anyway, no humans have to touch it. Once you bring it up, everything runs by itself. They call it the DAO. And that is fueled by the technology, which is blockchain. Okay? Then you say, well, but wait a minute. Terumi said that blockchain was a ledger system. How can all these very exciting things, like getting rid of Uber, happen because there's a distributed ledger? How does that work? Right? And that's what I thought. I said, well, how does that work? Okay? Because when you say ledger, it sounds kind of boring. But if you say DAO, it sounds pretty exciting. Okay? Yeah, it's all in how you frame it. Okay, so what I also did, and it's kind of hard to see, but because I'm a realistic person, I've worked in businesses before. It says, but look, Uber adds value, right? That's why they're there, right? Remember I told you about the insurance and all this stuff, and they do all the dirty work so the drivers don't have to. All we do is we pay percentage, and they take care of everything for us, right? So they have the help desk, so the clients don't have to contact me directly and complain that my car smells like doggy. I have a couple of dogs. But anyway, or they got dog hair on their clothes because they got in my car or whatever. They'll talk to Uber and not to me, right? So there are a lot of nice things about having somebody in the middle. Okay? And what blockchain, though, in the end, I've heard someone say on one of the TED Talks in blockchain, they said, look, how I see blockchain, not me, right, that person, how I see blockchain is that it's a hybrid system. That is, you have the centralized mixed with blockchain. So there are certain things that's going to still be centralized, like maybe support, right? Maybe these insurance type of stuff, because scale counts, isn't it? So if you're working with another company, like let's say insurance companies, they're looking at the scale and how much money they're going to make from scale, not just by individuals. So maybe for those kind of things, you still have to have some centralized part of it, but a lot of parts could be decentralized. So that's what this person said, and I have a tendency to agree with them. Because I couldn't check off all the nice thing that Uber does just because there's blockchain. Right? There's still things left over. And because if I were to think and say, okay, I think I'd like to come up with a system based on blockchain that will replace Uber tomorrow. If that's the case, I wouldn't know how to solve some of these issues. Right? Yeah.
Question. You talk about having blockchain replacing Uber.
Yes. Yep.
Trust anchor. If Uber is considered a trust anchor, you know the reputation of Uber, you know the communication service,
sure.
you know the authentication service.
Right.
If you take away Uber, where's your trust anchor?
Yeah. There you go, right? So, and that's basically, that was my question. Like, well, we still need trust, right? We still need trust. And centralization is how we are used to getting trust. And if you get rid of that, then, how does that work, right? So, I'm hoping that when I get to the technology cut, when I start talking about each of the features, technology features of blockchain, that's supposed to be the trust anchor, so to speak. Right? So if you could hold off on that for a little bit, at the end, if you could ask me a question one more time, hopefully that will clarify a little bit more. But great question, thank you. All right, so there are many industries that are supposedly going to be disrupted. So financial, healthcare, right? Medical records. And right now, if you talk, the reason why the brain comes up is because I keep on adding stuff to my brain when it comes to this. I know, I kind of do like the name, the brain. But anyway, so the healthcare and the insurance, right? Because you have the centralized, whatever the organization, vetting for everything. You have to go to the hospital to get your medical records and all that. But Bitcoins, right? So the protocol, which is Bitcoins, won't be able to support that because it's only about cryptocurrencies. But you have a product called Ethereum, and Ethereum is able to incorporate data with cryptocurrencies. So it's possible, you would think. But then the question is, yeah, but how come? What if I'm really, really like sick, and if I'm, constantly going to the hospital, and my data is like huge, right? Like, how am I going to put my X-rays and all that stuff? I'm not exactly sure how that works, and I have a feeling that you have a separate repository for those kind of bulk, huge data, but the main activities that you do, the fact that you went to the hospital, the fact that you're taking certain medications and such, probably will be on the blockchain. So I don't know the exact implementation, and there are some implementation being started nowadays, but you have to go and check the individual examples, see how they're disrupting. But they're saying that healthcare and insurance, supply chain management, right? Supply chain management. So they'll talk about Amazon, right? They say, okay, Amazon going away. Okay, all right, if you say so. Google going away. Okay, if you say so. eBay going away. Okay, all right. Okay, but anyway, I laugh because it's okay. But the thing is, there's a lot more to, let's say, Amazon than just selling stuff, right? So, but anyway, putting that aside, that's the kind of talk that you hear, right? So you have forecasting like sports and stocks, etc. They're saying that look, you don't need like a central researcher telling you, how the stock's going to do or whatever, right? So forecasting will change. IoT management. Now this I can see. Right? Because I'm more of technology, so Internet of Things. Right? So let's say you got a bunch of cameras. I could see how they could talk to each other with blockchain. I could see how they could be peer-to-peer, right, and be managed. So you don't have to have a central PC managing all these, cameras, let's say, from one location, that they can talk to each other. Now, that I can imagine. Energy management. Yeah, energy management. That is, I was in Japan when the big tsunami hit, right? And I was up in the northern part of Japan where the tsunami actually did hit, right? And where I was at, there were a bunch of people with solar panels, right? But none of those people had electricity when the tsunami hit. The reason why is because they weren't saving it for themselves. They were selling it back to the energy company, and of course, energy companies went down, so nobody had them. I said, wow, that's crazy. But still, the energy was being managed by a central organization. So what they're saying here is that, look, no, right? You got the sun, you got the panels, you have your own repository of your energy. You can sell it to whoever you want using blockchain. Go direct, yeah.
There's an article saying that blockchain mining is the most energy-intensive.
Mining, yes,
The
mining part, yeah. So we'll talk about that. It's called proof of work, yeah. So we'll talk about that in technology section. That's very good because that's a very big part of where the trust is supposed to come from. Okay, all right. So energy management. Sorry, that's funny, right? So, I need bitcoins because I'm spending money for mining. Sorry. And government and military, right? So the reason why I'm doing this talk is because I went to the AFCEA, right? And they were talking about blockchain and how DoD is very interested in blockchain. And I'm not exactly sure if they actually have something that's already started as a project, but anyway, so there is an interest there. Okay. So these are the industries and a lot more, right, that may be disrupted. Okay, all right. So that's the solutions cut, right? Kind of gives you lots of possibilities, okay? And people are making money, right, hand over fist, some of these companies. But there are a whole bunch of startups, and not all of them are reputable, right? So if you know the terminology, something called the Vaporware, right? It's like a balloon that you kind of put up and say, hey, I have this great idea, and I need a lot of money to make this real, right? And you'll be the first one. You'll make a whole bunch of zillions of dollars, and then of course the bubble bursts, right? So the Vaporware is where you don't have it, but you talk as if you have it. But when you get the money and when you try to make something, it doesn't come true, right? Because it's much harder than they thought. Okay, there are a whole bunch of them like that. So you have to be careful, right, when you're investing. And usually, even in this crowdfunding, like Kickstarter, I'm not sure if you know Kickstarter, there's been not just blockchain, but there's just been projects that people have said, wow, this is great, and they put a lot of money and nothing happens, right? And so there seems to be a lot of that going on with blockchain-related startups. Not to say all of it, but because it's so easy, right, to talk about it and talk about the kind of stuff that I just talked about and make people really, really excited, but not really thinking about the details. Okay? Anyhow, so let's take a look at the technology cut. Okay, just want to check and make sure that I'm still within time. Okay. I've been talking for an hour already?
Yep.
That's impossible. Oh my God, I only have... That's right. You have a coin that says that's when I started? All right. Okay. All right. You cannot change it. That's right. I can't change the past. All right. Trust in the trustless. I thought it was kind of poetic. But what must be true for the system is so that you use it, right? So that you use it, okay, to be trusted. Example, I'm going to use Bitcoins. Because it's been out there the longest, right, as far as I know. So the originator of the transaction is in, so what must be true, right? So the originator, so whoever is saying, I send you money, right, of the transaction is in possession of the funds being transferred. Yeah, well, you got to have the money before you could give it away to somebody, right? So you must know that the system makes sure that you do have the money for reals before you try to give it to somebody, okay? And there's something called the double spend problem. That is, it's like having a copy of a file, like a Word file, right? You say, okay, I have this Word file. I make a copy, I give it to you. I make another copy, I give it to you, right? So it's so easy in the digital world to make a copy and give it away, okay? But what is a crypto coin? It's just a file. Right? I make a copy, I give it to you. I make another copy, I give it to you. Okay? That can't happen, right? So this one, even though it's technologically possible, you're not supposed to be able to do that with money. You can't just make your own money. Okay? So, because it's worthless. Right? It's worthless in that way. So you have to be able to know. It says, okay, the system makes sure that you can't give away something you don't have. Okay? And the originator of the transaction has obtained the funds by one of the means commonly recognized as valid. That is, right, you can't, there are actually ways to get money in an unnatural way, okay? There are ways of doing that. But they're saying, look, but that's not legit, right? You have to have obtained the money or the cryptocurrencies in a legitimate way, okay? And there are only a couple ways that you can get bitcoins, right? Who knows? What's one way of getting bitcoins? Mining, right? Right, that's right. So if you mine and if you win, right now you get like 12.5 bitcoins, okay? So just imagine, right? One Bitcoin, like $6,000. Whoa, all right. It's like 40,000 whatever bucks, okay? That's a pretty good deal. And so every time somebody mines, and we'll talk about what mining is, right? Money is created. That's the only way in Bitcoins where money is created. There's no other way the money is going to be created in the Bitcoins. And there's actually a upper limit to Bitcoins. So I think we're talking about like 2110 or something. Where all the bitcoins are supposed to have been created, and then it stops, right? So then you play with what you have inside. Or, so the second way is somebody sending you bitcoins because you've done services and you get paid by bitcoins. There you go, right? Any other way, you shouldn't have gotten bitcoins, right? There's no other way really to get it, right? Okay, so you can't create it yourself. All right. As an outcome of the transaction, the recipient will now be recognized by everyone as being in possession of the funds being transferred. Okay, so I sent it to you. Now everybody says, okay, Terumi doesn't have it now. Now, Betty has it. Everybody, right? So that's the key, everybody. Everybody means not everybody, but we're talking about majority of people participating in this says, okay, we agree. Money just transferred, right? That has to be true, okay? And the fourth thing is, as an outcome of the transaction, the sender will not be able to present itself as being possession of the funds anymore. They said, look, I just gave away 2 bitcoins. I don't have that anymore. I can't say, oh, I still have the 2 bitcoins. Cannot. This would be the root of double spending. Okay? So these are the conditions that must be true for someone to participate in this. You see? So even though I'm describing bitcoins specifically, I'm talking about in general, anything that has anything to do with blockchain will have to hold this to be the truth. And if the system doesn't provide this, then I don't think you're going to have a truthful system. You may be gypped out of money, you may be able to double spend, it's just going to break apart. Right? So, but I think the cryptocurrency field is a good example of this. Right? So, from the bird's eye view, right? So you have the coin layer that we talked about, and then you have the protocol layer, and then you have technology layer, right? This is basically what I told you about. You have the blockchain in the bottom, and then you have the protocol, which is Bitcoin, and I put it with the capital B because it's not the coins themselves. I'm talking about how you exchange Bitcoins, right? So that's why I call it protocol. And then on top, I have Bitcoins or Ether or whatever, right? I have the coins, and I have the data in the application, right? So that's basically the technology layer. So if this is the case, where does the trust come from? I'm going to skip through this but if you're interested, please take a look at the slide. I've broken down into more topics for each of the layers, right? So I'm not going to be going through that today, but it's there for you if you want to take a look at it, okay? So I'm going to skip through some of these because it's just the details, right? Just the details. And here, even though you may not be able to see it, I have blockchain at the top, and the blockchain is divided into 2 technology areas. One is security, right? And the other one is the ledger, right? Remember, Bitcoin has to be distributed ledger, so there has to be technology involved with how do you implement that ledger part. And then where the trust comes from is the security part, right? So that's why I have them broken down into 2. And I have the typical security thing going on here. So, for instance, if we're talking about security, we're talking about protection of something, right? Protection of IT. So we're talking about data, whatever processes data, right? Whatever stores data, okay? Whatever transmits data like network, right? You have to protect them because data flows through them. So if any of these things are able to be tampered with, then people can actually tamper with data, right? That's why we have to protect them. And wherever you're displaying it, whoever touches the data, right? So before coming here, I've actually purchased a called a lockbox. So it's where you store your bitcoins and stuff, but it's like a USB device, okay? And what's kind of really scary, I'm really paranoid about stuff because I lose things all the time. And I forget passwords all the time. It's like, right? So in order for me to initialize this thing, they say, look, Terumi, if somebody finds out your password, all your money's gone. I said, what? Right? So they actually gave me a lanyard to connect, but I didn't trust the lanyard. I said, but I could drop this thing and, this thing could be cut, so I put 2 lanyards around it, right? But anyway, so they gave me like 23 words that I have to remember in the order. And so it's like 23 words, and they're nonsensical words. I mean, if you put it all together, okay? So if somebody takes it, and if they want to, handle and connect it to my online application or something, or take my money away, they have to be able to kind of bring back those 23 words. And of course, I can't remember them. So I wrote them down in the paper. But when I write them down on the paper, it's like writing down passwords, right? It makes me feel bad, right? So what do I do with that? I guess I have to put it in my, safe or something, but I don't have a safe at home, so I guess I have to bring it to a bank. Oh, no, bank is being disrupted, right? So what to do? Yeah, so anyway, so with security, but that's how it is, right? With blockchain, they say, look, I have a whole bunch of blockchain. I'm a millionaire. Oh, but I forgot my password. Oh, sorry, if you forgot your password, you can't draw down your money. You see, that's an issue, right? It's an issue. So what that means then is if somebody were to be able to get my password, and if they get my token, they can be me and work with my tokens, right? That's the security part. They don't tell you, that's not really directly related to blockchain, but how do you use blockchain? Well, by using these devices, and they call these wallets and stuff. So the security of those things still remains, right? It's not that, you can't trust the fact that that person who just gave you money is actually Terumi. It could be a hacker, right? It could be anybody. But the fact that whoever that is has access, proper access to those funds, the system allows it to work with those funds. So there's a big caution, right? When you're working with these kind of distributed systems, right? Because there is no central locus of trust in this case. You can't go and say, well, the person just sent me like 2 bitcoins, but how do I know that was really Terumi? There isn't anybody who's going to be able to tell you that. If they have, not that I know of, okay? All right. So security too, right? So what do we have to protect? Confidentiality, integrity, availability. So confidentiality is usually done by encryption. You say, I don't want people to know what I have in here. But as I mentioned to you, in Bitcoins, at least in the Bitcoin version of it, there are other versions where everything is like encrypted, so you can't really see what's going on. But with Bitcoins, you can see what everybody did, right? So encryption is not, confidentiality is not the big part of it. Now, the confidentiality of tying back the account to the real person, as I mentioned, is a big part of it, okay? So that's how anonymity is held, but it's not because it's encrypted or anything like that. Well, certain parts are encrypted. Integrity means people can't change it. Now, this is a big part, right? So we'll talk about how blockchain implements this integrity. That is, people can't just say, oh, instead of Terumi sending 1, she sent me 100. What, right? Just add 2 zeros. What's the matter with that, okay? So you have to make sure that people cannot do that. Right? And availability, that is, I have access to it. So whenever I want to use it, it's there, right? You can't tell me, oh, network's down. Sorry, Terumi, you can't get the money, or whatever, okay? So those things are important when it comes to security. And authenticity of source. Now, authenticity of source is This is where it says, oh, okay, Terumi just sent me money, but how do I know it's really Terumi? So I just talked about that, right? You don't, right, in most cases. Right? It's someone who has access to Terumi's account. That's basically what you get. Okay? And then non-repudiation. Non-repudiation means, hey, Terumi, I've actually sent you 2 Bitcoins. What happened to that, the dog shampoo that you're supposed to send me? That's a pretty expensive dog shampoo. Yeah? I said, what are you talking about? I didn't get the money. Well, what do you mean? I sent you the money. You said to pay me by Bitcoins, and I sent you by Bitcoins. That's not me. You must have been talking about somebody else. There are a whole bunch of Terumis in the world. Must not be me. Okay? So that's a non-repudiation, right? And there's a danger of this in Bitcoins because there's a tendency for the money to go past and the thing to go after, right? So it's like you have, which one comes first? The thing first or the money first? Either way, you have problems. So non-repudiation is an issue. Okay? Because if it were centralized, let's say Amazon, okay? So I order books all the time, from Amazon and stuff. And because they're so big, if I say, hey, I paid you the money for it, but I haven't received it. What's going on here? If the Amazon said, but I sent it to you. I didn't get it. It's possible that they left it in front of my door and somebody took it. It happens all the time, right, in Hawaii, so I'm just not used to this thing happening. But anyway, so it's gone, okay? Well, Amazon usually says, oh, that's fine, we'll send another one to you. Yeah, okay, but now if you're talking about peer-to-peer, right, if say, well, Terumi, send me those, very expensive dog shampoo. What? No. You have to send me money first. I sent you the money. Oh, I didn't get the money, right? So there you go. Okay? So that's the non-repudiation part. And that part, it's kind of hard with Bitcoins. And so security IT resources, right, managed by placing what's called access control. So encryption is a huge, huge part of security in Bitcoins, right? Encryption technology or cryptographic technologies, not just encryption. Okay? And if you have cryptographic technologies, then this thing about confidentiality, integrity, authenticity of source, and non-repudiation is usually handled. It's usually handled, okay, with encryption. The only thing that doesn't handle it is availability. You can't encrypt away the availability issue. So with availability issue, now you have distributed systems, right? So now you don't have central location where things can fail. So if a bank goes down for some reason, now what happens to your money? Right? How many of you watched the Mr. Robot? Yes, Mr. Robot. Definitely watched season 1. I know it's like season 4 or something right now. Season 1, they're trying to take down the bank, right? Huge bank. They said, look, everything's in paper form. Let's burn it. If we burn it, you can't tell how much money I owe, right? Or you can't, right? So that's what they're trying to do. Is burn the thing and just disrupt the financial organization in a little bit of a different way, not the blockchain way. just zero clear the information. So that part, by having it distributed, right? You have to get most of the network for that same problem to happen. So there is no single point of failure. Okay? But what the blockchain folks fail to tell you, right, is that when you have things that are distributed, there's a tendency to be more complex, right? And complexity that really adds to security issues. Because if you have things that are complex, they have a tendency to kind of break in a way that you don't expect. Okay? So it's really hard to kind of see the whole thing when things are so dispersed. Right? It takes a lot of brain power to coordinate these things. Right? So that's the downside of availability or the distributed system, but that's what blockchain has. Okay? So encryption. There are basically 3 major types of encryption, but I'm not going to go too much into it. The symmetric encryption is like encryption, right? When you want to hide data. But here in blockchain, we're not much into that. There isn't really much use to this part, but there are other uses. Now, given the last 15 minutes, I want to talk about this one. Asymmetric key encryption. Now, this one, once again, if you hear about somebody talking about public keys and private keys, that's what they're talking about, right? Asymmetric. The asymmetric encryption is used for digital signatures in this case. Okay? Asymmetric encryption is used for other things too, by the way. Right? It's used for key exchange, but that's not part of this talk. But you have to sign. If you want to do digitally sign, you have to have these 2 keys. Okay? And by the way, those 23 phrases, that I had to put in that little thingy, well, the key is in there, right? So the public key and the private key is in that little thingy, okay? And if I don't remember the passphrase, I can't get to it. If I can't get to it, I can't sign it. If I can't sign it, I can't do transactions, right? Because there's no proof that I sent my money, right? I have to be able to say, yep, I signed and vouch for it, and that's digital signature. So if you can't get access to the keys, you're not gonna have a transaction. And here's a very interesting one, right? This is very big in blockchain. It's called one-way encryption or hash. Okay, hash. And so hash is like fingerprint. Okay? So the fingerprint is supposed to be unique to you, right? Is it? Is it possible that somebody could actually have the same fingerprint as you? 61 million and one. You know? So one person in 61 million people supposedly have like a possibility of having exactly the same fingerprint. It's like, what? Okay. So, but the thing is, the way it's supposed to happen is that the fingerprint is supposed to be unique. So these are some of the assumptions that we have to make about hash, right? So in the cryptographic world, yes, hashes do have problems, right? It's supposed to identify, it's supposed to be a fingerprint for a piece of data, and it's not supposed to be the same with anything else. So if you change something, the fingerprint is supposed to change a lot, okay? But there is a problem called collision. So the collision is that 61 million issue. That is, you can have two different sets of data that will produce the same fingerprint. And there are certain equations or algorithms, that we call them ciphers, that has more issues with collision than not. Okay? So if you hear about blockchain uses something called SHA-2, right? Or SHA-256, right? Secure hash algorithm. And there's something called MD5 and SHA-1 that has been known to have problems with collision. So, but anyway, so how does this get involved with blockchain? Obviously, I have too much information than I could give you right now, so I'm going to skip through and just going to show you something. So I'm going to show you a hash demo, right? So hash demo. So here is the fingerprint using SHA-2, and what I'm going to do is, even though you probably won't be able to see too well, I'm going to type in here something like, aloha. Right? So if I type aloha, and please give it a try once you get home. Say that again? It changes, right? And if I just add like one period, even though you can't see it, it changes a lot, right? So when you make even the littlest changes to the actual text, the hash is going to look way different. Okay, way different. That's why it's called the fingerprint. Okay? So how do these fingerprints relate to blockchain? Well, here is, and let me skip to the blockchain part. So there are a bunch of examples that I have. So here's the blockchain ledger. So blockchain ledger is composed of multiple data unit called blocks. Right? So right here I have block 0, block 1, block 2. And then all the blocks contains record of multiple transactions, right? So like I give money to somebody, somebody gives me money to me, whatever, right? So those information is in each of the blocks. And they are connected together. Each block is sequentially connected, okay? So if you put them together right now, if you go to any site where you can actually see what's happening with blockchain, you can see the what's called the Genesis block. It's the blockchain ledger block that started the whole world of blockchain. Bitcoins. Satoshi Nakamoto purchased, the very first one, and you'll be able to see that because that's like the first block. And then there's like zillions of blocks afterwards, but that's the ledger. It has a complete record from the inception of Bitcoins all the way to now. And there's supposedly every new block every 10 minutes right now, right, being added. Okay? So it's growing. And so each block is sequentially connected with the next block by chains, right? So that's why it's called blockchains. So, but what's a chain? Well, chain is just a piece of data, okay, where I take the previous block, right? I take the block, and I put it through the hashing algorithm, like SHA-256, right? Put it through the algorithm, and then I put the hash in a location in the next block called the previous hash. So everything about block 0, which is the hash version, goes in as piece of data in block 1. And what's so nice about the hash is that there's limited size, right? So for example, no matter how small the thumb or the pig, right, it's never going to be as much information as my whole body itself, right? And I could be 5 foot tall, I could be 6 foot tall. You still have pretty much the same size of the fingerprint, right? So you can control the size. So that goes into the block. Then what happens to the next block, which is next 10 minutes? What would happen then is I'll take the whole block, put it into the SHA algorithm, come up with the hash, and then put the hash there, right? So what happens here is if somebody says, look, I'm going to change Terumi's transfer of 2 blocks, 2 bitcoins to 20 bitcoins. If they were to make that change in that ledger, then the hash will be broken, right? Because even the littlest change is going to create a huge change in the hash, and that hash is embedded into the next block, right? So from the location where you changed it, everything really gets broken. The chain is broken from ongoing if someone were to make those changes. So it's really hard to get away with changing anything that happened in the past. So this is the part about the immutability, right? They're saying immutable, it's not that you can't change it. Yes, you can change it, but it's really hard to keep everything kind of in sync, right? And so that's one of the supporting technologies on that. So all transaction blocks in the ledger are visible to the public, okay? So everybody can see it. And this is just a little thing about digital signatures. Every time I do a transaction, remember the block contains several transactions. It doesn't have to be just mine, okay? But let's say I do a transaction. I digitally sign that transaction, okay? So digital signature goes with it, right, in the transaction. So that you can always say, did Terumi do it? Or whoever is being Terumi do it? And they'll be able to see that and say, yeah, right. With the digital signature technology, at least you can narrow it down to who done it, right? Or whose account was this, right? Not really an individual per se, but someone who has the access to the account. So there's the digital signature part, which is also security, okay? And there are nodes. So let's go into mining, right? So the complete set of ledger is maintained by several nodes. We call them nodes, right? And the complete set, so I'm talking about the beginning of Bitcoins all the way to now, and it's growing, right, every 10 minutes, is held by what's called the mining nodes. If you want to do the mining, you get to be in the mining node, and we'll talk about the importance of mining. And then everybody else, not, right? They only check about their transaction, make sure that what they did is correct. Whereas the mining node has to make sure everything makes sense. No new money was created in an illegal way. Everybody did fine. And what happens if somebody who's mining lies, right? There's that always a thing. You don't trust the miners. I mean, they're just another node. What if they come and say, well, look, I'll change the 2 to 20, and Terumi, look, I just changed that for you, so you give me like 5, right, for me to do that. So I'm just going to, change this thing. Those kind of things could happen, but it's very hard to happen in blockchain because not one person could say that's the transaction. You have to have 51% or more people agreeing to the fact that that has happened. Okay? So this is called consensus, right? So this is how you don't have to have trust, right, of individuals, but you have to have trust of the majority. So the majority rules in Bitcoins, okay? And in blockchain as well. So what happens here, and I'm not going to do the example of the hashing because it will take too much time. I do want to kind of get to the point, but if you were to access my slides, you'll get to playing with the hash, okay? But what I would like to show you is this one. So let's see. So here, this is a block. It's another block. It's another block, right? And the hash of this is here, right? Previous hash. And the hash of this, including the hash of that, right? Including that data, is here. And that's how it gets chained, okay? So if I were to change something, like if I were to change a data here, notice that the hash of this now changes, So all the recorded hashes have to change, right? It turned red, saying, look, there's something wrong with the hash here, right? It doesn't match anymore. Okay? Not only that, not only does it not match, if we were to do the same thing where several people have this information, so let's say there's the first people on top, and then you have the second person that has the exact same ledger, and you have the third person which has the exact same ledger, and then let's say this first person changes something and says, okay, I'm going to change 2 from 2, to 200. Notice that that person will have to fix whatever is happening on that line, but guess what? Everybody else still stays the same, right? So now, if the hacker wants to be the majority, hacker will have to contact almost everyone, well, over half, and make the same change, right? Okay? But remember, things are moving all the time, right? Every 10 minutes, new information is going, right? So it's very hard to keep up. So what they're saying is that it's not that you can't do it on the system. It's not that you can't change maliciously something that happened in the past or something that only helps you to make money, right? But it's hard to get the majority of the people, right, to agree to it. And if the majority doesn't agree, guess what happens? They'll look at you and say, Terumi, you're a minor, but your calculation, there's something wrong with that. Nobody's agreeing that that's what happened, right? What happens? They'll cut you off, right? They say, we don't trust you anymore, okay? So that's basically what happens with blockchain, okay? It's not that there's a central authority, but the 51% of the people says, nope, that doesn't match, right? And then they'll say, you probably did something wrong out of there, right? That's basically what happens. It's very, very interesting. Not that there aren't faults with it, okay? So the blockchain ledger, copies of the complete set of ledger, all transactions are held by all nodes identified as miners, okay? And if they're mining, held by miner is not the same as the majority of others, its version is rejected, okay? And there's actually a penalty to that. There's a penalty for coming up with a ledger that doesn't match with over half of the people. And if an attacker wanted to tamper with the ledger, it must tamper with over half of the nodes holding the ledger, which is dynamically changing. Very, very hard is what they're saying. We're talking about thousands and thousands of nodes, right? And if you're just a one node, or maybe 100 nodes, not enough, right? You have to get 51%. Right? So the ledger is considered immutable because the source of attack is not realistic. It's just not realistic. Say, look, there's just too many people out there that I have to convince. Okay? And that's the fear of centralization. So if you have centralization, they think that it may be easier to get 51% agreement if you have centralized somewhat. That's why we want to keep the Bitcoins in a decentralized peer-to-peer. There is no hub where this possibility could exist. Right? But there's actually some issues with this. Okay, so I'm going to skip through that. Sorry about that. So this is a distributed blockchain. By the way, the blockchain looks almost like this. So basically, you have the Genesis block where there is no previous. So it's all zeros. It starts at all zeros. And then you take this, and then there are transactions, right? From Anders to Sophia, 10 blockchains. All those things go in. And then you take the hash of that and then keep on going, right? That's basically what blockchain looks like. So I'm going to skip through this. So I think I have enough time to talk about proof of work, right? Just 1 minute, right? Proof of work is, remember, if the miners, right, lie, then it's really hard, right, to prove what's going on. So what you want to do is you want to make it very expensive for the person to lie if you're a miner, right? So in blockchain, the reason why people say, well, blockchain, like, it wastes energy, what they want to do is they want you to spend a lot of money and a lot of time trying to add a block. That is, trying to say, look, this is the proper data. Okay? You want to make it really expensive. Okay? And then once you have to compete amongst miners to say, my version is the version that's going to be added to the block. Okay? And it does take a lot of money, right? They say that with the Bitcoins and Ethereum, I think over $1 million, I think maybe per week or something is spent on just trying to calculate and trying to compete being that. But if you win, right? If you win, you get like $40,000. And this happens every 10 minutes. Just imagine how much money you can make, right? Okay. So anyway, so there's something called the proof of work. And this is supposed to keep the consensus, the 51% consensus, honest. Right? So just summarizing, okay? Sorry, I had to kind of go through this very quickly. Summarizing, now, is there security, right, in blockchain? There is, right? So how does the trust in distributed system comes from in blockchain? From consensus, right? And if the consensus doesn't work, then the trust is not going to work. In addition to that, there are other types of security, such as hash. Hash does have problems, right, as I mentioned, okay? And digital signature. The problem that I see here is that there is really no way right now for a lot of the Bitcoin systems to tie back to an individual because there is no centralized authority. So if somebody does actually steal your account, that's it. Okay? So blockchain is still in works, right? But it's been enough. It's been over close to 10 years and working that a lot of the industries are really, really looking at it, like IBM. Is in the major way in the game of blockchains. And you'll probably start to see actual implementation and actual disruption of certain industries due to blockchain. But is the trust there? It's still in the works. Okay? Hey, thank you so much for your attention, and I hope you learned something new from it. Right? Thank you very much. Okay.